Okay, you're asked to find the critical numbers for this function right here. This red graph right here is the graph of that function. So to find the critical numbers, we want to find the derivative of that function, which I've rewritten here as f of x. So we're going to have to use the product rule. Here's the first function times the derivative of the second function, where I use the chain rule to get this factor, plus the second function times the derivative of the first. The derivative of this exponential function is just like the derivative of e to the x is e to the x. The derivative of 4 to the x is 4 to the x, but you have to multiply by the natural log of the base, ln of 4. Okay, and we want to know, when does this expression equal 0, or when is it undefined? It's kind of obvious it's defined everywhere, so we want to know, when does it equal 0? I've kind of rewritten it here. I could have said 4 to the x times 4 is 4 to the x plus 1, but I'm going to end up factoring out a 4 to the x, so I just left it like this. So here's the 4 to the x, and e to the 2x squared I can factor from both terms, leaving this binomial expression. 4 to the x remains from the first term, and natural log of 4 remains from the second term. Now, all these expressions multiply to give an answer of 0. So by the zero product property, either 4 to the x equals 0, or e to the 2x squared equals 0, or that binomial equals 0. I don't care what value you put in for x here, you'll never get an answer of 0. Ditto for this. So we want to really know, when does this equal 0? That happens when x equals the natural log of 4, the opposite of the natural log of 4 divided by 4. And here's what that value is, negative 0.34, blah, blah, blah. Okay, and this dashed line is the graph of the derivative. And you can see this column right here. Here's when the derivative is equal to 0 at this value of x sub 1. So that's where the graph has a horizontal tangent line. You can see that the first derivative is negative to the left of there. That means the original function is decreasing to that critical value. And to the right of that critical value, the first derivative is positive. So the original function is increasing to the right of that critical value. So this point right here has a relative minimum for the function, and actually is an absolute minimum. Okay, there you go. Hope that helped. If you have any questions, post a comment.